Hi everyone! In this video, we will talk about the different concepts and approach to chemical equilibria. First is the nature of chemical equilibria. Chemical equilibria refer to the state in which a chemical reaction reaches a balance between the forward and reverse reactions. In other words, it is the point at which the rate of the forward reaction equals the rate of the reverse reaction, resulting in no net change in the concentrations of reactants and products over time. This dynamic state is characterized by the establishment of an equilibrium constant, which quantitatively describes the ratio of product concentrations to reactant concentrations at equilibrium. Chemical equilibria are governed by Le Chatelier's principle, which states that when a system at equilibrium is subjected to a change in conditions, it will respond in a way that minimizes the effect of that change. This principle allows us to predict how changes in temperature, pressure, concentration, or volume will affect the position of equilibrium. One key aspect of chemical equilibria is that they can occur in both homogeneous and heterogeneous systems. Homogeneous equilibria involve reactions where all reactants and products are in the same phase, like all gases or all aqueous solutions. On the other hand, heterogeneous equilibria involve reactions where reactants and products are present in different phases, like gas-liquid or solid-gas reactions. The second concept and approach to chemical equilibria is the classification of electrolytes. Classification of electrolytes refers to the categorization of substances based on their ability to conduct electricity when dissolved in a solvent such as water. Electrolytes are compounds that dissociate into ions in solution, allowing the flow of electric current. This classification is essential in understanding the behavior and properties of different electrolytes. There are three main categories of electrolytes. First is the strong electrolytes. Strong electrolytes are substances that completely dissociate into ions when dissolved in water. They have a high electrical conductivity due to the presence of a large number of ions. These ions can freely move and carry electric charge through the solution. Examples of strong electrolytes include strong acids like hydrochloric acid, strong bases like sodium hydroxide, and soluble salts like sodium chloride. In a solution of a strong electrolyte, the concentration of ions is high, leading to efficient conduction of electricity. Second is the weak electrolytes. Weak electrolytes are substances that only partially dissociate into ions when dissolved in water. They have a lower electrical conductivity compared to strong electrolytes because only a fraction of the molecules dissociate into ions. This partial ionization results in an equilibrium between the undissociated molecules and dissociated ions. Example of weak electrolytes include weak acids like acetic acid and weak bases like ammonia. The degree of ionization depends on factors such as concentration, temperature, and the nature of substance. And the third one is non-electrolytes. Non-electrolytes are substances that do not dissociate into ions when dissolved in water. They do not conduct electricity because they lack free ions and can carry electric charge. Non-electrolytes are typically covalent compounds with no ionic character. Examples of non-electrolytes include sugar, like sucrose, alcohol like ethanol, and organic compounds. Although non-electrolytes do not conduct electricity, they can still dissolve in water and form solutions. The classification of electrolytes is based on the extent of ionization or dissociation in solution. Strong electrolytes completely dissociate into ions. Weak electrolytes partially dissociate, and non-electrolytes do not dissociate at all.
The third concept and approach to chemical equilibria is the nature of acids and bases. C. Nature of acid and bases. Acids and bases are two types of chemical substances that are essential in understanding many chemical reactions and processes. Acids are substances that donate a proton, whilst bases are substances that accept a proton. This proton transfer reaction is known as a neutralization reaction, and it produces a salt and water. For example, When hydrochloric acid is mixed with sodium hydroxide, the following neutralization reaction occurs. HCl plus NaOH to NaCl plus H2O. In this reaction, the hydrochloric acid donates a proton to the sodium hydroxide, which accepts the proton to form a salt and water. To determine if a substance is acidic or basic, we can use the pH scale, which measures the concentration of hydrogen ions in a solution. A pH of 7 is neutral, while less than 7 is acidic and a greater than 7 is basic. The fourth concept and approach to chemical equilibria is the dissociation constants for weak acids and weak bases. D. Dissociation constants for weak acids and weak bases. The dissociation constants for weak acids and weak bases are important parameters in understanding the behavior of these compounds in solution. The dissociation constant Ka or Kb is a measure of the strength of the acid or base, and it is related to the degree of dissociation of the acid or base in solution. For example, the dissociation constant for acetic acid is Ka is equal to 1.8 times 10 raised to negative 5, which indicates that the acetic acid is a weak acid. Similarly, the dissociation constant for ammonia is Kb is equal to 1.8 times 10 raised to negative 5, which indicates that the ammonia is a weak base. And with that, we have learned the different concept and approach to chemical equilibria. Thanks for watching!